Hi, everyone. It's so great to be here. I'm local to Miami, but I'm still getting to know the people that are here, the resources that are here, and the creative energy that's here. So I'm hoping that after this talk, we can all chat and get to know each other a little more. As Clay mentioned, I picked up this moniker, the Robot Whisperer, but this was not a career path that I ever set out to make. And to be honest, it really just happened by accident. I'm actually an architect by training and just a roboticist by practice. And so it's really a big joy to be in a room of people dedicated to interdisciplinary research and really trying to break down the silos of academia, which can be, the structure is nice, but it can be quite limiting in the application. And so as someone who comes from the world of the arts and wandered into tech, I think it's really important to remember that culture is a technology. And that culture was even the first technology, and maybe even the best technology ever for transferring knowledge from generation to generation. And so that's why I see digital tools and technologies as creative mediums unto themselves, and that they're really vital for exploring the futures of the human condition. It's our R&D department of culture. All right, with that being said, let's get to the robots. So the world of robotics and AI are really starting to merge, and you might have seen some terms like physical AI or embodied AI start popping up. And all that really speaks towards is about putting intelligent software into physical things, into bodies, into robot bodies. And robots really have become our fears of AI made incarnate. And in all reality, robotics has been a very niche field for the past 50 years. But it's been commercializing very quickly. And that's bringing us face to face with a lot of our anxieties around automation and really just a reminder or a threat of our own obsolescence. But here's really what we need to remember as people who create technology, as people who put technology out into the world that's going to touch millions of lives, that automation is not inevitable, it's intentional. It's a series of choices that we have collectively made, and I believe it's about time to start choosing differently. I'm really passionate about inventing better ways to communicate with machines that can make things. For a long time, industrial robots have been the culprit of automation and replacing human labor. Basically, all the easy tasks to automate have been automated. Now what we're working on is using these tools to enhance or augment human labor. And that to me is very exciting. Industrial robots are really fantastic CNC machines. You put a different tool at the end of the arm, and all of a sudden they can do a whole different thing. So in the morning you can be doing spot welding, in the evening you can be doing painting. It's just highly adaptable. Another thing that I'm working towards is finding ways to bring these machines out of factories and into live environments. So onto construction sites or onto film sets. There's chance for unpredictable objects like people to be moving into the environment. That's one of the reasons why I wanted to build the system, to give this robot eyes so that it could actually see me and we can safely collaborate in a shared space. If I'm wearing or if I'm holding these motion capture markers, it knows where I am in space, it knows how I'm moving in space. Now all of a sudden we can give the machine a nuanced understanding of our intention in that space. You can get someone who's never seen a robot before and have them begin to do creative things with just a couple minutes of interacting with the machine. So somehow, some way, I have built an entire career out of properly misusing machines, for taking them for what they are and having them do nothing that the engineers who developed them ever expected. And this project in particular, I'm quite fond of. It was done about 10 years ago, almost to this day. And I never really understood why no one had taken these motion capture cameras that can see the world but not move, and this robot that can move in the world but not see, and just slap them together. It seemed really, really obvious to me. And then I found out the reason why. It was because I never read the manual. And the manual, which on page 31, warns you of your impending demise. Manipulator movements can cause serious injury on users, especially for applications that involve close human contact with their robot. But to be honest, it was a really good thing that I never read the manual. And sometimes not knowing what you're not supposed to do is an incredible unlock. Because I would have never discovered that the interesting thing about robotics is not really what they're doing. That's not the most interesting part. What people were excited about was this perceived connection to it. That just because of how this thing was moving, I stopped being a programmer and I started to feel more like an animal tamer standing in front of this big, giant beast of a machine, totally in love with it and really hoping it wouldn't crush me. And that unlocked a big realization for me that almost everyone in robotics industry is getting wrong right now. And that is that the future of robotics is not about function, it's about feeling. It's going to be about how they make us feel. The tasks that a robot can do are really just table stakes. But if you want adoption and acceptance, then we really need to work on how they make us feel. And for that, that's a far more interdisciplinary problem that our educational structures have traditionally been set up for. And this is it's a little bit frustrating to be revisiting this point because it's something that we learned a long time ago. So I don't know if most people know this, but the birth of robotics in industry and the arts really have the same origin story. In fact, some of the first engineers that were working by day developing machines were building art and sculptures at night. And even to the point where we have these autonomous mechanical creatures. This one in particular is really cool. It uses sound. Those are microphones on its proboscis that's looking for people. And so this happened like over half a century ago, and it's something that we forgot. And so I often think back to this moment of time in the late 1960s when we were just beginning to experiment with robots. We were just beginning to define and explore what a robot is. And I wonder, what would it look like if all of the economic forces that pushed us towards robots that were efficient and optimized and repetitive were instead reconfigured to be curious, kind, and alive? So let me introduce you to Mimis here. She is a very curious industrial robot. And I had the good fortune of inviting her for a 6-month holiday from her factory assembly line in Birmingham, UK, into a design museum for her to hang out and just exist with all of the people there. This was a really cool project for me. It was my first time that I could take all of these ideas that were incubating in the lab and bring it out into the wild, into a cultural setting, to come face to face with groups of people that had never even seen a machine before like this. And over the course of the 6 months, about 100,000 people had experienced and had some time with her. And it was a big difference from my PhD user studies, which kind of recruited 6 to 12 people to get their feedback on it. So this robot in particular is no different than any other robot that you would see on a factory assembly line building cars. The only thing really different is that she's not holding any tools. It's just her face bare as she was born from the factory. And so the only thing that I did is I just went inside and I tinkered in her brain and I gave her a personality. And just by changing how she moved, I gave Mimis this illusion of life. And I discovered that this illusion of life was a really powerful tool for interacting with intelligent technology, autonomous machines, robots, things that have agency in the world. And to be honest, I didn't discover this principle. There's literally a book called The Illusion of Life that some Disney people folks wrote back in the 80s. And if, in fairness to me, I didn't know this book existed when I worked on that. But they didn't discover that principle either. In the 1940s, these psychology experiments would put little pieces of paper, these squares and circles and triangles in front of people and ask them what they're seeing. And no one said, I see 2 triangles and a circle in a rectangle. They say, I see a big, giant bully triangle trying to get at a scared circle. And they started to breathe these characters into these things. It's the foundation that we have for animation. And they didn't discover this principle either. This is a phenomenon called pareidolia that's hardwired deep inside all of us, across our cultures, and across all time. And it's the reason why we see shapes in clouds. It's the reason why we see constellations in the stars, a face in the moon. It's why we see face in almost anything. And it's a really powerful design material that we have yet to harness. And so here's really the biggest secret that I hope we can embrace. Us humans, we need very little to make us see something that is alive. We're really, really easy to trick, and humans are amazing at seeing animacy in everything around us. I've taken my robots around the world, and everyone thinks that their eyes, their cameras are in their face, but those are just holes for screws that we automatically assume are eyeballs. In fact, my robots, most of their cameras are distributed in large environments. But you can also just slap 2 giant wooden circles onto a 10,000-pound robot, and all of a sudden you have this roaring creature eyeballing you and your friends. And then you also get the world's largest googly eye, which is pretty cool to make. And at the end of the day, this is not a bug, it's a feature. And it's hardwired into all of us. And it's a really powerful medium for communicating with machines. So many of us these days find ourselves saying incantations to machines, hoping that they give us magic in return. And so what do we do? How do we convince these machines, not command them, to listen to us? And so I tend to structure my approach around 3 principles that kind of drive my creative inquiry. I think about amateurism, playfulism, and optimism. So amateurism is about using eyes that can connect dots that others can't see. It's a powerful tool, and it's really hard to keep that open-mindedness the more expertise you gain. And that's something that now, as I've, a decade into this, I have to battle that because now I'm the expert, right? And so I always have to be on guard for these blind spots that my expert assumptions make. This is too hard, that's impossible. All these things that you start to self-censor at the beginning come with expertise. But the one thing that really brings me a lot of comfort as we're moved to the future at rapid pace is that when technology moves as fast as it does today, it makes us all amateurs. And that really levels the playing field for innovation. Playfulism. So a lot of this idea about playfulism is about leading with curiosity that's open but intentional. And I took this approach one day when my husband and I decided to purchase a dilapidated warehouse in Pittsburgh and convert it into a warehouse house. And the idea, the intention behind this was that we were going to, I didn't want to just go visit my robots from 9 to 5, Monday through Friday in the lab. If I really wanted to see what it's going to be like in our future to live with these machines, then we would need to become roommates. So we moved in together. This was, anyone who's done a home renovation knows there's a lot of blood, sweat, and tears involved in it. But we had this amazing living space, a studio space, about 2,000 square feet of studio space, and then a workshop space that we ended up finding out that we needed to convert into a nursery. So our daughter was born here amongst the robots. And while we were doing the renovation, we needed a place to put her where she wouldn't eat the construction material off the floor. So we built a swing in the warehouse, and she had such a good time doing that I thought, maybe my robots would want to feel outside their body and go for a swing a little bit. And that kind of what if question led to something really productive when during lockdown, this pandemic baby had some companionship to swing with her while she couldn't go out and play with the other kids. So I believe that purposeful, powerful play produces profound potential. And I always like to end on optimism. I am an optimist by nature. It's like deep inside me. And you can find it in a through line with all of my work. But I'm also a skeptical optimist. And that's really about acknowledging the challenges of today, but still fearlessly and relentlessly drive to bend the future towards more desirable directions. And where we're going, there is no roadmap. There's no career roadmap for this for sure. And you can really only navigate by the stars. And being able to set a North Star gives a lot of space for ambition and idealism, and also leaving rooms for zigs and zags, for tempests and tailwinds, all the while keeping a very intentional goal. As you create the work that you make, think about what is your North Star. What can you build towards fearlessly, with relentless optimism and intention that maybe is too idealistic, maybe is too ambitious, but you can put a whole career into making that happen. I believe that we have the technology today to build the futures we want. Now we just need to misuse it. Thank you. And while I have the microphone, and I'm amongst friends, and this is a safe space, I also want to say that I'm looking for interdisciplinary tenure track positions. I'm based here in Miami. I would love to stay here in Miami. And so I'm hoping that if you know someone or you're interested, you can call me and we can have a conversation about that. So that concludes the TED Talk portion of the keynote. But I have some behind the scenes here, and I'm also hoping that we can open up for more of a conversation. So if you want to talk about some of the software I've developed, simulation software I've developed to drive these human-robot interactions, we can do that. I get really nerdy about simulation software. I get really nerdy about sensors. And so anything you want to talk about is fair game. And then also for the students in here, career paths. Literally there is no roadmap here. This January, I found myself in Paris at Fashion Week, which I would never get invited to Fashion Week if it weren't for robots. I was invited by Izumiyaki to develop this scenery, minimalist scenery, for these big robots moving in space. It's a Japanese minimalist brand, beloved by architects and designers all over the world. And it was such a cool experience to be able to sort of LARP in this world of fashion. So this was probably the simplest program I've ever written for any robot in my life, but it was the absolutely most challenging experience as well. I was brought in 3 weeks ahead of time. I'll show some behind the scenes, and then maybe we can open it up for Q&A. I was invited onto the project 3 weeks ahead of time, and it was with really talented folks from Europe and Sweden who do not work over the Christmas holiday. So we had kind of 2 weeks to do the whole project. And you can see here that these robots were driven from a truck from Sweden, delivered into the Latin Quarter in Paris. Somehow we found a forklift. The forklift wouldn't fit inside of this 18th century church that we were inside of. And all the while, we were kind of like construction teams and video teams and lighting teams, and us robot people were building on top of each other within the 72 hours to transform this place. And so this is just, if you've ever wondered, like, how do fashion shows, like, happen, this was kind of the madness behind it. So 24 hours before, like, the floors were almost done. They weren't even painted. 2 hours before, everything is getting set up. They're doing photography. 20 minutes before, we're all kind of, like, crammed into this little corner, me with my little computer that all I had to do was press one button and hope that the robot started synchronously. And then afterwards, there's a really beautiful exhibit. But that was like, it's a really cool way to live your life when you can do things that other people can't do. When you misuse technology, it opens up like a lot of interesting doors. You have to be comfortable with ambiguity and comfortable with not knowing what's just down the road. But it's been a really wild ride. I have lots more behind the scenes stuff, but maybe we can save them for questions, and I can use that to help answer some questions. So I think we have some microphones up here that we can hand out, if there's any.
Hello. So an architect by student, and then your journey into Carnegie Mellon and robotics. Talk a little bit more about that background, or what is that pivot to? How'd you got in?
Yeah, so I graduated actually down the road at FIU from a school of architecture in 2008 and 2010. And what also happened at that time was a global recession where there was absolutely no jobs in architecture. And so I thought, this would be a good time to specialize in something. And so I continued on at Carnegie Mellon University. And I didn't know what to expect. I wanted to become a museum curator, but I didn't get into that program. And I happened to get into this highly technical program that I had never written a line of code before going there. And it was a really painful process to learn how to talk to machines, computers, or robots. And these things, though, what I found is that I was able to like take this amazing expertise in computer science and interaction design from Carnegie Mellon and apply it to my deep knowledge of space, how bodies move through space, how to organize through that. And it happened to be at the same time where robotics was really moving into architecture from the standpoint of manufacturing, advanced manufacturing. So the robots were there. They were just doing boring stuff. So I just, went in there and took like my lessons for calculating change machines in Python and tried to like build some bridge to creative applications for these machines. And a lot of the innovation that I think I can bring is taking the sensibilities of an architect, the advanced engineering of a roboticist, and the poetic sensibilities of an artist, and kind of like smashing them all together. And just by being able to bounce in between these different silos of knowledge, you can combine and create things that just take what already exists in the world and reconfigure them to show different possibilities. How many people here love the software side of things? Who's hardware? What is hardware versus software? Software, my people, hardware. One of the reasons why I use robots is because they're supposed to work like 100% duty cycle, 24/7, and I don't know anything about robots or electrical engineering or mechanical engineering. I just want it to work. And so I come from the world of software. This is some kinematic software I developed in open frameworks. I'm a big proponent of open source software, about sharing knowledge, about no one else having to go through the pain that I went through to learn these techniques and to get as many people going in as many different directions as possible to find the solutions that we actually want with these machines. This past year or two, I've been building my own cable-driven robots, and so I've learned a lot about mechanical engineering, electrical engineering with that way, but I can also see the pain of not knowing if when there's a bug, if it's a software or a hardware problem.
So what's the next step for you? What's your moonshot that you would love to work on or to do?
That's a great question. I've been thinking about that a lot lately. I think that we're moving into an era where our technology is making magical realism real. And so that's been my North Star a bit. I'm looking into sentience and how we can begin to design for sentience. I think that that's kind of the era that we're moving towards. And that might not necessarily be with big, giant industrial robots. That might be with the things in our home or the cars we take or every little thing that technology is beginning to find its way off of our screens and into our physical environments.
I have a question concerning, you started your talk by saying you want to give robots feelings. And the last video you showed us was about fashion and models where the models are told not to show any facial expressions. The spaces are kind of white, super clean, almost antiseptics. It's kind of, I find it surprising that, you paired with them first to exhibit what you've been doing.
Oh, that was a cool gig. That was like getting the band together, right? So like the bat signal went up in the air, like, let's go do this. Yeah, 2 weeks to go do this. So that was just a really cool experience. I mean, my role in that was really technical development. And so what I did, because we didn't know, I'm a tool builder by nature. And so we didn't know what the music was going to be until the night before. We didn't know that there was actually choreography at the end and that we needed a finale until half a night before. And so I built some sketching tools that made a really efficient live coding workflow to go from these things that are, usually it takes 4 to 6 months to integrate a specific procedure for industrial robots. Like I'm sure a lot of people here have never even touched an industrial robot because they're such dinosaurs. They're such like ancient ways of working with them. And so I try to bring in workflows and systems that help bring more iteration, more feedback, more experimentation into that. So that I was just a part of a larger team on that, and it was like too cool an opportunity to say no to.
And interacting through conversation at the same time?
Oh yeah, definitely. Let's listen to its voice. Let's see, where are we? Oh, I can't turn up the volume. Let's see. So these things roar. They have a voice. Their voice is in their motors. They can chirp. You move its base and it rumbles. You move its head and it chirps at you. And so, here we're giving a little bit of eyeballs to it. I'm having some fun with it. But I'm very big on using the maximal minimalism of these things. So, I'm not entirely convinced that this thing that is so alien, that doesn't look anything like us, should have like a human-like voice or conversation. It makes a mismatch between its abilities and my expectation of it. And so keeping it kind of raw, keeping it kind of animal-like, presents like a legibility between its limitations and my expectations.
Hi. So you mentioned some of the hardware.
Oh, sorry. Oh, go on.
So you mentioned some of the engineers and the roboticists doing art at night. And as a creative technologist, how do you feel that your work informs some of the more traditional roboticists and engineers in the field?
Yeah, my audience goes from curators at museums to developers in the Bay Area, right? And so a lot of what I try to do with this is to get these ideas out. There's really a lot of power in the default code that comes with a product. So for example, when I was at NVIDIA, we were working with building an autonomous robot to patrol inside their headquarters. And even the idea of it patrolling, the terms used there, like there's a surveillance, there's a security aspect to it. And so I said, why don't we use the same thing for wayfinding? It's a guest, it's a host. It guides you from the entry to where you need to go, rather than for policing people. And so even just shifting a mindset from kind of the most obvious and logical application to shifting it towards a different default that's just a little bit more desirable is kind of what I see my role to be. Let's see, I have a diagram of this that I really like. This is from the futurist Stuart Candy, and he talks about, like, how do you think about the future? He talks about it like you're holding a flashlight, a torch, into the night sky, and you have like a quick beam right down the middle. And that's industry, that's the probable thing that's gonna happen. And as you get wider, you get to the possible future, and that's where I see research. That's the researcher's role, to really explore the possible futures out there. And then at the very, very fringe, at the fringe of that fallout, you have this preferable future, so what we actually want to happen. And I see that as the role of the arts, that the arts are there to kind of push at the edge of possible and impossible to try to get the probable to move a little bit more towards its direction. So next week, actually, the reason why this talk is structured kind of in two sections is because I'm going to a developer conference for Figma and giving a keynote there. So it's a chance to, again, get these ideas in front of 8,000 developers to think about how does sentience, how does optimism, how does kind of like creative technology led by artist-led innovation, how does that actually enter into products that go out and touch millions of people? There's some questions up. Oh, here's one.
So when you're talking about the imitation of life, and you're talking about how, such as humanoid robots going forward, that there are functional applications, and then you really want to focus on how they make you feel. What do you see people doing today that are building these humanoid robots or other robots that is good, and what would you like to see them do more of that maybe isn't being taken into consideration?
That's a great question. I don't even think they realize this, but I think Disney Robotics is going to win the future. I don't know if you've seen some of their humanoids running around the parks. They have bipeds. They're not even humanoids. They're these little robots that are programmed to kind of walk like chickens and ducklings, and they're cute and they're communicative, and they're from their Star Wars universe. And I think that you know, animators and also like dancers and choreographers, they understand how to get things to communicate with their bodies through space. And if I were Disney, I would be doubling down on investing there. But I don't see that happening right now. I see Hyundai and Boston Dynamics. And Boston Dynamics is going to have an entrenched lead. It's been the first to commercialize. And it's doing things that I think are very useful. You know, if I can bend the future towards the direction that I want, I would love humanoid robots, bipedal robots, robots that share our spaces with us to do less service jobs, less of being servants. Oftentimes, when you think about the examples that people give for what they want robots to do, it's cleaning, it's taking care of people, it's laundry folding, and all of those things are traditionally domestic work, undervalued work done by women, also done by immigrant women. And so this idea of like devalued labor, we're going to devalue even more. I would love for those to be like, if I could be king for a day, I would protect caretaking as a human-only job and make those jobs not suck, actually pay them and with benefits and structure, and do the robotic stuff for the dirty, dull, and dangerous, which is traditionally the domain of robotics. But I think there's a lot with entertainment. Like, so much of our world is based off of entertainment and engagement. And who wouldn't want to live their life with like a spirit, their own very own spirit animal, their very own piece of magical realism walking with them throughout their life? I think that would be really cool.
I think, great, fascinating talk. I have currently, robots, as you said, are mostly, and artificial intelligence in overall, it's more about kind of taking tasks, human tasks, so to speak, and do them well. And many think that the true test of where we have real artificial intelligence and a physical body as a robot is if we have a robot that can make coffee in somebody else's kitchen. When do you think that will happen?
I think we already have coffee robots in our kitchens.
coffee robots in our kitchens, but a robot making coffee in somebody else's kitchen.
Like if the robot is undercaffeinated, it's going to make some.
No, a robot go there and recognize the kitchen, recognize the coffee machine, which is not the same coffee machine that you may have, recognize how to make coffee, and make coffee in somebody else's kitchen. In our kitchen, absolutely. We can program anything, any intelligence to do anything, right?
I see.
But how we can actually create an intelligence that can go and make coffee to some random kitchen, not in our kitchen.
So my approach for a lot of this is not to. I sort of believe that solving a problem and avoiding a problem get you to the same solution. And so for here, general intelligence in unstructured environments is a really hard problem, and that's a decade problem, and it's probably going to be closer to a decade with all the advancements we've had and how everything is accelerating. But you can just have a Wi-Fi enabled coffee machine and log into my mom's coffee machine and make her a cup of coffee in the morning by pressing a button, right? And so the output, a lot of these things that we want, the output, the imagination, we have an avenue towards the output. And oftentimes we're trying to figure out how the technology can get shoved into it in a certain way. So I'm always about avoiding the hard problems instead of actually like running through them. Cool. Well, I'm so grateful to be here with you all, to meet with you all. Come up and talk to me. I'd love to chat about tech and robots and any nerdy thing. And thank you again for having me.